So today we are going to be discussed about compiler design. This course is for under Nagpur University, 6th semester, computer technology at Kids Around Tech. Now I would like to discuss about compiler design. So what do you mean by compiler design? Or else we can say, what do you mean by compiler? So where can we use compilers or compiler tools? What is the definition of compiler? So we'll see the word compiler. Compiler is a tool. We can say a compiler is a translator. So a compiler, it compiles from high level collect our files and compiles and translate it from high level language to low level languages. For example, if you see anything high level language, you will take the Java. So Java is a high level language. So Java as usual is there. So system cannot understand. So system can able to understand only the machine language. We can say binary language, zeros and ones. If whenever program we have written in high level language, if we give to the system to execute the program, system cannot able to execute the program. So what shall we do for that? As a computer engineer, so we have to think that one all these high level languages should be translated into lower level languages. So that is the major work of compilers. So compiler always translates high level language to low level language. Now we see about what are the phases of compiler. It's the major thing in the compiler design phases of a compiler design. So in this phase of compiler, there are six phases are there. First one, lexical analyzer. Second one, syntax analyzer. Third one, semantic analyzer. Fourth one, intermediate code generator. Fifth one, machine independent code generator. Sixth one, code generator. So finally, if you reach that one, machine dependent code optimizer. Apart from this, there are two additional phases, symbol table and error handling. The first phase is lexical analyzer. So what do you mean by lexical analyzer? We think that the first phase in a compiler design is lexical analyzer. So in this lexical analyzer, so we will give a input as a program. When we give input as a program, that lexical analyzer reads the input data. We can say also this as a scanner. Lexical analyzer is a scanner. So this scans the input file, that means character by character. It makes as a it reads a character by character and makes them as a tokens. What do you mean by token? A token is a group of characters, or else we can say a string. A string is a token. So this token will be passed to the next phase, that is called syntax phase. So this syntax phase receives input from lexical analyzer as a token stream and generate output as a syntax tree. So what is there in the syntax tree? So in the syntax tree, this syntax analyzer, it reads all tokens one after the other, token by token. It reads and it makes that token into a syntax tree. So in the syntax tree, we identify very carefully input, what is the input, what is the output. So clearly we have to specify in that. So syntax analyzer, it makes each token as a one identifier. Each character we can make it as a each character as a one identifier, or else each string is a one identifier. Based on the identifier, it generates a syntax tree. If syntax tree is generated, then easily we can analyze what is the input, what is the output, what should we pass to the next phase. So the next phase is a semantic analyzer. So one more name of this semantic analyzer is type checker. So it checks the type. What do you mean by type? So why to check the types? If you are not checking the type, what will happen at the time of execution? For example, you have given a in the program space, you declare the variables like a int. Int is a some data type. For this data type, you declare int a is equal to 10, or else int b is equal to 20, and int c is equal to a plus b. If you give like this, all these things, at the time of type checking, at the time of type checking, it checks whether the given data type is correct or not. If the data type is correct, then you will get the correct output. If the data type is given different way, for example, you see variable declaration int a is equal to 3.5. So this 3.5 is a decimal value, but integer never ever accept decimal values. It will accept only the plain number. So that is why this semantic analyzer, before at the time of execution, it checks type checking the given input variable is correct or not. If it is correct, then that output pass to the next phase. So that next phase is all called as a intermediate code generator. So this intermediate code generator receives input as a syntax tree and generate output as a three address code. So what do you mean by three address code? Why we call it as a three address code only? Why not four address, five address, six address? So there is a specific meaning is there for three address code. For example, if see A is equal to B plus C. So A, B, C is a operands and plus is a operator. So this is a proper syntax format for three address code. A is equal to B plus C. A, B and C are operands. Plus is a operator. So this is a common syntax. So in this case, what happened in the three address code? So in this three address code, again the given input statement will be rectified in a proper format. If the given format, the given statement is in a three address format, then the system checks it's correct. Otherwise, system will the execution will be stopped. So that is why we have to check phase by phase in a compiler design very properly. Then only we'll get proper output. So that is why the intermediate code generator, it generates output as a three address code. So in this case, one more thing it is there. So we have to compress the logic, or else we have to compress the total memory space, so that we can able to optimize the code. The main aim of three address code is we have to optimize the code, we have to reduce the memory space, we have to increase the execution speed. So that is why the most vital role plays in the intermediate code is that only. It improves the system execution speed and reduces the memory space. So that is why where your program is presented at set primary memory, so immediately the system it will fetch it and it will execute it. So time will be saved. Otherwise your program is too lengthy, your program is executed fragment by fragment, fragment by fragment, fetching data from secondary memory to primary memory, again primary memory, again it is identifying. This will take more time. So that is why the intermediate code it will improves the execution performance and decrease the storage of your memory. That is the main thing of intermediate code generator. The next level is code optimizer. So in this code optimizer, again it will be reduces the three address code memory space and increases the execution speed. For example, if you take, if there are at intermediate level, there are four temporary variables are there: t1, t2, t3, and id1 is equal to t3. When it comes to code optimizer, out of four variables, it will make it as a 4 becomes a 2. Only one temporary variable t is equal to t1 and id1. If you go in details like this is there at intermediate code, t1 is equal to into 2 float 60, t2 is equal to id3 into t1, t3 is equal to id2 into t2 plus t2, id1 is equal to t3. When it comes to code optimization, this 4-line code will be reduced to 2 lines code. t1 is equal to id3 into 60.0. Then id1 is equal to id2 plus t1. See how nice this one code optimizer. 4 lines will be reduced to 2 lines only. So that is why intermediate code gives push up to the next level code optimizer. This code optimizer totally optimize the code. That means compress the code. So your output is same. Whatever you have given in input, you are expecting same output at the code optimizer also there is no change at all, but input is, if you are given something, you will get the output also same, no change at all. So that is why code optimizer improves your system execution performance and reduces the memory size. Finally, you think about code generator. So this code generator, this high level language will code will be converted into assembly language. So this assembly language directly understood by any operating system. For example, you take my operating system is I'm using a Windows 10. If you use somebody else Mac OS, somebody may use like a library open office, some other operating system they may use, somebody may use some other linux, somebody may use, but at any system, all the system can basically understood binary languages. So that is why in a compiler design, whatever program you have written high level language, that program will be converted into machine level language. That machine level language is a one of the machine level languages, assembly language. This assembly language directly understood by system. So that is why we can convert again this assembly language into binary language that is done by our system. So that is why in a compiler, mainly compiler always it compiles the program and also it translates high level language into low level language. So this is the basic things of phases of compiler. Thank you to all.